So good evening, my dear students. Today we are going to start with the next module, module 3, dynamics. So already we have completed almost the 90% of statics. So next module 3 and 4 is the part of dynamics. And you know that dynamics is the branch of mechanics which deals with bodies in motion under the action of forces. So the syllabus for module 3 and 4 I have already uploaded in Google class, so you just go through it. So when you start with this module, so my suggestion is that first of all you write down the contents of this module. So if you see the syllabus, the first topic of this module is components of velocity and acceleration along radial and transverse direction. So transverse direction is also known as the cross radial directions. So before starting with this topic, it is better to know about the terms what is velocity and acceleration. So when you talk about the velocity, first you should know about the displacement. What is displacement? It is the change in the position of a particle in a certain interval. So if we take the rate of change of displacement, then it is known as velocity. And it is well known to all of you about acceleration, that the rate of change of velocity is known as acceleration. So in this topic, actually we are going to discuss about the velocity and acceleration along the radial and transverse direction in case of a polar coordinate. So we'll get the velocity and acceleration in case of polar and in case of polar coordinates. So you are well familiar with the polar coordinate system. So in Cartesian coordinates, you know that we consider the coordinate x and y, but in polar coordinates the coordinates are r and theta. So just to look at the figure, the first to see the topic. So what is the topic? Components of velocity and acceleration along radial and transverse direction. So transverse direction is also known as cross radial direction. So radial means along the radius vector. So just to look at the figure, so let OX and OY be two perpendicular axes on the plane of the motion, and P is the position of the particle at time t with polar coordinates r and theta. Refer to O as the pole and OX is the initial line. So we have considered I cap, then J cap, R cap and theta cap are the unit vectors along OX, then OY, then OP and perpendicular to OP. Now these unit vectors R cap we can resolve into two components. So just to look at this coordinate R cap. See this coordinate R cap, if we resolve into components form, we can write A1 I cap plus A2 J cap. So from P, so if you see the figure from P, if you draw a perpendicular on x-axis, so along x-axis the unit vector is I cap. So the direction we can consider I cap, and magnitude along the x-axis we can consider A1. Same way from P, if you draw the perpendicular, then along OY the unit vector is J cap. So the vectors along the perpendicular drawn from the point P we can consider A2 J cap. So this R cap by addition law of vectors we can write as A1 I cap. We can write this way just to see A1 I cap plus A2 J cap. Now if you take the dot product of this vector R cap with I cap, so you know the dot product between two vectors, vector A and vector B. So dot product between two vectors, vector A and vector B, is defined as it is the magnitude of the vector A, magnitude of the vector B, and cos of theta. So here if we take the dot product between R cap and I cap, so here in this equation you are taking the dot product with I cap. So what you will get, as because you know that I cap dot I cap is 1, but I cap dot J cap is 0 because angle between them is 90 degree. So after taking the dot product of this, what you will get, it is the magnitude of the unit vectors R cap, magnitude of the unit vectors I cap, then cos theta. Theta is the angle between the vectors. If you see, theta is the angle between the vectors R cap and I cap, and in that case you will get A1 is equal to what? You will get A1 is equal to cos theta. Same way if we take the dot product of R cap with J cap, if you just to look at the second part, if we take the dot product of this vector R cap with J cap, then we will get A2 is equal to sin theta. So thus the vector R cap can be written as it is can be written as it is I cap cos theta plus j cap sin theta. So this vector r cap we can write as I cap cos theta plus j cap sin theta. So just to look at the figure, so this vector r cap, it is possible to resolve in the components form. So what is the components forms? In terms of polar form, we can say it is the I cap cos theta plus j cap sin theta. So here theta is the angle between r cap and I cap. So similarly we can write down the expression for this theta cap also. So what is the angle made by this line along the x-axis? It is the pi by 2 plus theta. So similarly, see, just to see the expression for theta cap. So theta cap, what we can write? Theta cap we can write it is I cap cos pi by 2 plus theta plus j cap sin pi by 2 plus theta. Now you know that you know the quadrant formula. Cos pi by 2 plus theta is equal to what? It is minus sin theta. So theta cap we can write it is minus I sin theta plus j cap sin pi by 2 plus theta is equal to what? It is cos theta. So theta cap, what is the expression for theta cap? It is minus I cap sin theta plus j cap cos theta. Okay, now what we'll do, we'll differentiate this equation 1. So you just to see this equation, the first r cap, what is the expression for r cap? The expression for r cap is what? The expression for r cap, we are getting this one, it is I cap cos theta plus j cap sin theta. So if we differentiate equation 1 with respect to t, so what expression you will get? You will get it is, so what is the differentiation of cos theta? That is minus sin theta. So differentiation with respect to t is denoted, we have denoted by this dot. So it is minus I sin theta plus j cos theta. And when you differentiate this theta, d theta by dt, we can write as theta dot. So thus r cap dot can be expressed as it is theta cap. So just to see this expression, this is nothing but the theta cap. So this r cap dot we can write as theta cap dot I cap. Okay, again differentiating this equation 2. Okay, now you see the equation 2. If you differentiate equation 2 with respect to t, then you will get, see here, what is the differentiation of sin theta? You will get cos theta, minus is there, and cos theta is equal to minus sin theta. Ultimately, after taking minus common, what you will get? It is I cap cos theta plus j cap sin theta, and d theta by dt you will get theta dot. So same way we can write almost in the similar manner, we can write theta cap dot is equal to what? This is nothing but the r cap. You see the equation 1. This expression is nothing. This expression is nothing but the r cap. So we can write minus r cap theta dot. So now we have considered, see, you know that vector is equal to what? It is magnitude into direction. So along OP, what is the vector? Vector is r bar. So r bar we can write as r cap. R is the magnitude and r cap is the unit vector. So our intention is to find out the velocity. So the expression for velocity, see the expression for velocity we can write v bar. So v bar means what? Velocity of the particle p. And what is velocity? Is the rate of change of displacement. This r bar represents the displacement. So what we can write? It is d r bar by dt. So r bar is nothing but it is r cap. So now just differentiate this one by the product rule of differentiation. So say first function as it is, differentiation of r cap, what you will get? R cap dot. Second function as it is, differentiation of first. Okay, now take the help of the equation 3. So r cap dot we can write as what? R cap dot we can write as, see, theta cap then theta dot. So we just replace r cap dot by what? Theta cap then theta dot. And this part we are keeping, this part we are keeping as it is. That means the first second part we are keeping as it is. So from this we can write this term I have written as the first term, r dot, just to see, this can be written as it is r dot r cap plus r theta dot theta cap. So r cap is the unit vector along OP and theta cap is the unit vector perpendicular to OP. So here radial components of the velocity is the coefficient of r cap. So it is r dot. So we have denoted the radial component of velocity by what? We have denoted the radial components of velocity by vr. So vr is equal to radial components of velocity. This we can write as r dot, and the coefficient of theta cap is the transverse component of velocity or the cross radial components of velocity. So what is the coefficient of theta cap? It is r theta dot. So theta, this one we have denoted by b theta. This is what? Transverse component of velocity. So it is r theta dot. Okay, now next we come to the acceleration part. So what is acceleration? Acceleration is nothing but it is the rate of change of velocity. Just to see the expression, so f bar is acceleration of the particle or of the point P, so it is the rate of change of velocity. What we can write, it is d v bar by dt. Now v bar, you already know the expression for the velocity components. So velocity components, we can write the velocity components v bar is equal to what? It is r dot r cap plus r theta dot theta cap. So now we have to differentiate this one with respect to t. So after differentiating this one, so here we have to apply the product rule. Here three terms are there, so here also you have to apply the product rule, but from this you will get the 3 more terms after doing differentiation. So these are the terms you will get when you do the differentiation. So second part, when you do the differentiation, what we will do, this r theta dot we consider as one component, and theta cap we consider the one component, and theta cap will consider the second component. Then you do the differentiation. Okay, after doing the differentiation, you will get the 5 terms. So there r cap dot you replace by theta cap theta dot. So that one already we have obtained this expression, and this theta cap dot we can replace by what? It is minus r cap theta dot. So these terms we have to arrange, and we have to separate the terms along with r cap, separate the terms with r cap and theta cap. So the components which is the coefficient of r cap will give you the radial acceleration. So with r cap, what we are getting, just to see, with r cap you will get r double dot minus r theta dot square with r cap, and with theta cap you will get 2 r dot theta dot plus r theta dot. So here the coefficient of r cap will give you the radial acceleration. So what is the components for radial acceleration? So this one we can write r double dot minus r theta dot square, and f theta represents the transverse acceleration, and the expression for this you will get from the coefficient of theta cap, and it is given by 2 r dot theta dot plus r theta. So this part we can arrange little bit. So if we take common 1 by r, you will get this expression. Then these 2 terms is possible to express this way. The second term I have written this way, see r square theta double dot. Just to see, r square theta double dot, say r square theta double dot, we can write d dt of theta dot. The second term is possible to write theta dot, you keep as it is, and we can write d dt of r square. So if you differentiate this one again, you will get this part. So here we can apply the product rule of differentiation. So from the results of product rule of differentiation, what we can write, 1 by r you keep as it is. See, 1 by r we are keeping as it is, so we can write it is d dt of r square theta dot. So this fr will represent the radial acceleration, and f theta will represent the transverse acceleration. Now if you see the figure, say if at the point P, if we consider on the arc length, so it is a part arc length we are consider is a small arc length, so it may be a circle also. So in that case the r will be constant. That means in case of a circle, radius is constant. Then what are the results you will get in that case? So in case of a circle of radius a, we have r is equal to a. Just to say, r is equal to a is equal to constant. So in that case the radial, so if r is equal to a is equal to constant, so what is the value of r dot? So r dot you will get 0, and so this one will give you the radial acceleration. And same way we can find out r theta dot. This one will give the so radial velocity. This one will give the transverse velocity. So here we can write a theta dot. So these two are the components of velocity. These two are the components of we can say the components of velocity along the radial and transverse direction. So same way we can find out the components of radial and transverse components of acceleration also. Just to see this slide or this page. So radial and transverse components of acceleration. So already we have derived the radial components of acceleration. So what is the components? It is r double dot minus r theta dot square. So if r is constant, then the value of r double dot will be 0, and r we can replace by a, so you will get a theta dot square. So ultimately you are getting the radial components of acceleration in case of a circle is what? It is minus a theta dot square. And the transverse or cross radial components of acceleration, you see, we can write this expression 1 by r d dt r square theta dot. If you write down the expanded form, it is nothing but 2 r dot theta dot plus r theta dot. So r dot, if r is constant, it is 0. So ultimately what you will get? You will get r is equal to what? A. You will get a theta dot. So these two are the components of radial and transverse components. You can say it is the radial and transverse components of acceleration if we consider the point P on a circle. So this is the first topic. So based on this, you'll get the problem also. In my next class, I'll give you some more results, and after that only maybe we can come to some problems where we can take the help of these expressions. So hope it is clear. So I will uploaded all the materials in Google Class as well as RoyalNet. You just go through it. In case if you have any doubt, you can call me, or you can WhatsApp me, or you can share your feelings in Google Class also. You can just share what problem you face to understand the things, or which line is not clear. I can make it clear. So thank you all of you.